Let's say that you're building an app that stores a reading list. You might start by creating a variable for each book, like so. var book 1 equals Matilda, var book 2 equals Hamlet, var book 3 equals Macbeth. This works, but only barely. What if you wanted to add a fourth book? You'd probably create another variable. A fifth book? Another one. Now you have 5 disconnected variables with no real relationship to each other. You can't loop over them, you can't pass them around together, and you definitely can't easily scale this to a library of 100 books. This is exactly the problem that arrays solve. An array is an ordered collection of values, all of the same type. Think of it like a bookshelf. Each book has a specific position. The first book is at position 0, the second is at position 1, the third is at position 2, and so on. You can add new books to the end, slide one into the middle, or pull one off the shelf entirely, and everything else adjusts automatically. In this video, you learn how to create arrays, read values from them, and modify them using common operations like appending new items, inserting them at specific positions, and removing ones that you no longer need. Let's create our first array. In Swift, you declare an array like this: var books equals, and your list of books separated by commas in a pair of square brackets. Let's walk through what we're actually looking at here. Var means that this array can change. We can add to it, remove from it, and modify it later. If we use let instead, the array would be fixed and we couldn't modify it afterwards. Books is just the name that we're giving this collection. You can call it anything that makes sense for whatever you're storing. The square brackets are what tell Swift that this is an array. Whenever you see a list of values inside a pair of square brackets, you're looking at an array. And inside, each item is separated by a comma. These are our elements, the actual values being stored. Each one lives at a specific position, starting at 0. Swift sees the items inside and automatically figures out that this is an array of strings. You don't need to tell it explicitly. This is called type inference, and it keeps your code clean. If you ever need to be explicit about the type, for example when creating an empty array, you can write it like this. The type goes inside square brackets here, and that tells Swift what kind of values this array will hold. This type here can be anything that you need. It can be a string like it is here, or it could also be an integer, a double, booleans, a custom object, and more. One thing worth noting is all items in the array need to be the same type. You can't put an integer and a string in one array. They should either all be integers or all be strings. This is a feature in Swift, and it means that you always know what you're working with when you go to retrieve a value from the array. Now that we have our array, let's start working with it. To read a value, you use its index inside square brackets, like so. Print books 0. This prints the item stored at position 0. In our case, the first book on the shelf, Matilda. One thing that makes arrays reliable is that they're ordered and stable. The array will always maintain the sequence you created it in. Books 0 will always return Matilda, not because it's the first alphabetically or the most recently added, but simply because that's the position it was given when the array was created. The only time that changes is if you explicitly go in and change it yourself. You don't have to print values to use them though. You can also store a value in a variable or a constant like this. Let first book equal books 0. Now you can use first book directly without needing to write books 0 every time. To add a new book to the shelf, we use .append. This places the new item at the end of the array, or at the end of our bookshelf. It automatically becomes the last index. But what if you don't want it at the end? What if you wanted the book Coraline to be the 5th book on the shelf? That's where .insert comes in. You give it the value and the position that you want it at. This moves all of the other books over and inserts Coraline into its new position. Swift automatically shifts the other books over and nothing is lost. To remove a book, you use .remove and specify the index. This removes whatever is sitting at that index. In this case, index 2 is our 3rd book on the shelf. Just like with insert, Swift automatically closes the gap and updates the position of everything that comes after it. You can also replace an item directly by assigning a new value to that specific position. Here, we're going to replace the book at position 2 with Alice's Adventures in Wonderland. Whatever was at index 2 is gone, and the new value takes its place. The rest of the array stays exactly as it was. Let's go over a few more things. Bound safety is a very important concept to understand. Let's say we have this array. There are 5 books in the array, which means that the valid indices go from 0 to 4. But what happens if we accidentally try to access an index that doesn't exist? For example, books 5. If you run this, your app will crash with an index out of range error. This happens because Swift tried to access an item that isn't there. Index 5 is outside the valid range, so Swift stops the program to prevent undefined behavior. The key takeaway is this: you can only access indices that exist in the array. Every array in Swift has a count property. This is especially useful when you need to check exactly how many items you're working with, or when you want to avoid accessing an index that doesn't exist. In this case, it would return 5. One important thing to remember is that the count gives you the number of items, not the last index. Since arrays start at 0, the last valid index is always count minus 1.